Hello, fellow geeks. For the last few weeks I have been playing Death Stranding, a game with a lot of very well represented volcanic geological features. In this video, I will use this great game to explain volcanic rocks and some of the landscapes found both in the game and in real world. I will not mention any spoilers because I am just trying to provide a geological explanation of the rocks found on the game, but I will show images of different places, so if you are okay with it, sit down and enjoy learning about volcanic rocks. Volcanic rocks are part of igneous rocks, and more specifically, extrusive igneous rocks. This means they are formed on the surface of the earth from lava. And lava, for those who don't know, is just magma that has emerged from the underground. Volcanic rocks are easy to identify because they have a typical texture called aphanitic, which means invisible. Their crystals are so small that they are invisible to the naked eye. During an eruption, lava cools down very quickly, and this speedy process limits the available time that crystals have to arrange their atoms and grow. The lack of time is the responsible of the often glassy and dull look of volcanic rocks. So, there are three main volcanic rocks. Each volcanic rock is going to reflect certain physical and chemical properties of the lava. The basic idea is that darker rocks are different from lighter rocks. Darker volcanic rocks are formed by silica-poor lava, and silica-poor lava is called mafic. It has a low viscosity and a high temperature. On the other hand, silica-rich lava is more explosive and colder, and it results in what we call felsic rocks, which are lighter in color. These black mafic rocks are what we call basalts. Basalts are formed from generally extensive lava flows and are the most common volcanic rock on the Earth. Because they come from lava which flows extensively, all these layers are likely to be successive lava flows, one after another. And you may think, well, this is a lot of lava. It is a mountain full of non-stop flows. But there are cases, for example in the River Columbia, of lava sequences of more than 3 kilometers. Basalts are usually affected by an event called columnar jointing. Columnar jointing happens when very hot and dilated igneous rocks cool down and shrink. As their volume is reduced, they develop fractures that produce these cracks. They usually have 6 sides, but they can go anywhere from 3 to up to 8. In depth they are elongated like a pillar, but they are not always straight and they usually curve. In here we can see 2 sets of columns, which are likely to correspond to 2 different volcanic eruptions and 2 different lava flows. Basalts produce non-explosive eruptions, allowing the creation of extensive lava fields. It is usually very easy to differentiate between the most recent darker lava and the older and more wetter and lighter lava. The low viscosity produces tunnels which the lava uses to flow under the earth. And when the climate of an area is the correct one and the rocks have been sitting there for a good while, they may get colonized by moss. This happens already in Iceland, where some lava fields have this fluffy look. Anyway, not all the black rocks are basalts. Generally speaking, when mafic lava has too much gas, it results in explosive eruptions and a rock called scoria. Scoria is a very characteristic rock. It is black to reddish and full of holes called vesicles. These holes are the result of the gas that was dissolved in the magma at the time of the eruption. Lava explodes and solidifies at the time of the eruption, trapping gas and air inside the rock. This is a scoria cone, which is the classic volcano shape left after an scoria eruption. They are the most common volcano type in the Earth, and this one has one of the sides collapsed. But enough of these black mafic rocks. As magma increases its silica content, eruptions will be more violent and will lead to other kind of rocks. Intermediate volcanic rocks are halfway between mafic and felsic rock, so their color is, generally speaking, grey. The most important intermediate rock is andesite. Andesite is an aphanitic rock which contains also less iron than basalts, so they are lighter in color. They are common in the continental crust, above subduction zones. Last of all, we have volcanic rocks with a high silica content, which are called felsic rocks. The most important felsic volcanic rock is rhyolite, which is the volcanic equivalent of granite. Rhyolite is generally pinkish to grey in color, and the cool thing about them is that they may contain gems, such as opal. Rhyolite is a synonym of very explosive eruptions and a lot of destruction around. These extremely violent eruptions are associated with volcanic ash and pyroclastic flows. In this area, it is clear that the lighter ash was located along there. Volcanic ash is light in color, sometimes white, and it may result in lithification and formation of tuff, which is a rock with an ash content higher than 75%. Sam is looking here at some cool layers of tuff. Each one of them may be linked to a different volcanic eruption. This is an excellent tool for a geologist because it allows us to know how frequent volcanic events are and usually how old they are. There are some other volcanic rocks, but similarly to andesite, I didn't find good examples of them in the game. These are, for example, obsidian, also known as volcanic glass, which is formed by an extremely quick solidification of felsic lava. And we also have pumice, one of the very few rocks that float over water thanks to the many voids filled with air within the rock. So anyway, I have to say heads up to the developers, who made a great work which reflects reality but at the same time, it perfectly fits their own creative and non-scientific licenses. I hope you learn about extrusive igneous rocks, and most importantly, I hope that next time that you play Death Stranding you also check the outcrops while wandering around. Thank you.